Good deal. So what you have in front of you, a couple things, is the fourth 9 weeks syllabus. It's the last one. And I started to, like, holy cow, start to sweat a little. If you notice that we finalized Chapter 6, the Chapter 17 tests, and then we're starting Chapter 6, which is the, we have 6, 7, 8, and 9 left for probability and statistics. And so that's pretty much where we're going to be for the next couple weeks. On next Tuesday, please highlight, do whatever you do. It says 2 take-home tests, paper 1. I'm going to give you 2 take-home tests, okay? And they are for the paper 1.
Yeah.
And if you notice, you go down to the 20th of April, that's when they're due. Okay? I understand that in the middle of that is spring break. I am not telling you that this is a spring break assignment. I'm giving you a couple weeks before spring break and, you know, time after spring break. So if you want to do it spring break, by all means, please do. But don't say Ms. K is making us do tests over spring break, because that's not what's happening. Okay? You know, tests are about 10 to 12 questions max.
Yeah.
And you're going to have 2 of them. It's a really great form of review. It's a good opportunity for you to go, work with people, try to figure out what you don't know. Okay? So that's those are actually going to be turned in. They will be graded as if they're tests. They will be graded and entered in as a test grade out of 100 each. So that's 2 100 grades that you could potentially get. Yes.
So they're all concepts that we've covered for the take-home
Correct.
test.
It is what we just finished. It's 1 through 18 from that one book.
So like the, you know, like unit vectors and trig and calculus.
Stuff like in the
Inverse.
book where it's like there's one little part we don't know.
It's an actual test.
Okay, so
an
it's
actual test.
all example problems that we've done before.
Hopefully, cross fingers, right? Yes.
So on the 18th, when we have like the second set of take-home tests due, that's the day that we take our paper?
Yeah.
Okay.
Okay, so let's talk about how that works. So before I get to that, let's finish, because Chapter 9 ends on the 28th of April, okay? Chapter 9 potentially could last a little longer than that. So hear me out for a minute. We might do some fixing, arranging as we kind of think about it. Your actual ACE test is May 3rd, the following Wednesday. My preference would be to actually take that week that Chapter 9 is and just review. Review everything you need to know about paper 1, okay? Then, starting May 4th, start doing Chapter 9 and review for statistics, because you don't test until the 18th.
Yeah.
The only dilemma I have is that I'm not certain when you're going to be testing. You're not certain when I'm going to be testing. You know, there may be days that we're not together. I mean, there will be days that we are together, and that I will be able to teach you Chapter 9.
Yeah.
So if there's a certainty that we will be together till May 28th. My nervousness is that, you know, you might be out taking a test, or, you know, I might be out proctoring a test, and I want to have a review week, but I don't want to do it by jeopardizing Chapter 9. Yes.
So when does your testing start? Like, where you have to?
We start actually that week of the 25th, 6th, 7th, and 8th in the
April.
afternoons with marine science.
Is it after school tests?
No, they were from 1 to 3-ish. So, you know, we need to think about it, kind of really soul search and think. Would you rather me hold off on Chapter 9 and do it like in between, after you do paper 1, and then before you do paper 2? We can do that for a week and then review statistics. I think you're going to get a good review of statistics this next week or 2 that we start doing these lessons, because I think it'll, like we did last week where we started doing derivatives again and setting of the zero and solving for stationary, all that review started coming back. Yes.
Are we going to have a test on Chapter 9?
Yes. I'm trying to give you as many as you can for your final grade. Yeah.
Oh, so you were proposing that we do Chapter 9 after the
Shift
paper
it down
1.
to May 4th.
And then, so maybe in that time we could review for paper 1, like
Absolutely.
calculus and derivatives and inverse and all that. Yeah.
I think it's a good idea. I mean, I think the only thing is if we could assure that you would be able to tape me, then it would be good because then we wouldn't have to worry about somebody missing the class. They could go on and look after.
Right.
Or maybe somebody else could volunteer if you were testing to tape, and then you upload it to your whatever, however that works.
Because it doesn't really make sense to do statistics right before we're about to do the
That's
calculus
what we're worried
test.
about. I want
Yeah.
more than 2 days. I don't like
Yeah.
it. I don't like it at all. So that's my thought process. And plus, your take-home test is due that week before. We could actually go over them, review them, you know, that sort of thing.
Yeah.
That's kind of where my mindset is. So kind of put a little, if we do that, our test would be the 12th of May for, the 12th of May for Chapter 9.
Mm-hmm.
Which gives us time to study a little bit for the statistics, about a week. Yeah.
So essentially that whole week is going to shift to this week.
I would like to do that.
Okay.
Would you start at the 4th, the test, chapter 9 starts
Yeah.
at the 4th?
Yeah.
So what do you mean, like, your schedule on this, would it?
We could do 11th. Yeah, that
Maybe
gives
like
us
the 10th or 11th.
Well, 10th is a Wednesday, so it's a partial day, which I don't like. So maybe the 11th we could do, and then have 1, 2, 3, 4 full statistic review days.
Yeah, let's do that.
I think we should do that. So the 11th of May is test for Chapter 9. We're going to shift Chapter 9's week.
The 11th is the test?
I think we should do that, and then give us a few extra days to study. I think that'll be a good idea.
Yeah.
I really, really want to review a little bit paper 1. That way you don't go in going, oh, I don't remember how to set 2 things equal to each other and solve for X, you know. Okay, so that's that. Now, the next thing that I gave you is this AS final review sheet. This thing you can start working on anytime. This, to me, this is like, everybody has come back and said this is probably the most invaluable thing that we did for review. Having done tests every year, having done a week of review every year, and then this is the one that they love the most, okay?
Mm-hmm.
So here's what this is. So if you look at just the first one, when you see the words, so if something like this is somehow on the ACE test, if it says find the zero or roots,
Yeah.
okay, what should you be thinking and doing at that point? Yes. You should think about factoring. So what would you do before you factored?
B squared minus 4, is that one?
Nope.
Nope.
It's just, you would do what?
Set it to 0.
Set it to 0.
Right.
Then you would factor, okay? So you would take whatever you were working with, whatever trinomial, whatever binomial, whatever it is, you would one set it to 0.
Yeah.
Then you would start to solve for x, okay? So this is a real opportunity for you to kind of go back and say, if it indicates it wants zeros, how do I get zeros, okay?
Yeah.
Like, some of them are pretty self-explanatory.
Yeah.
Let's go down to number 6, for instance. Number 6 is something we just reviewed. It says, find the interval where f is increasing or decreasing.
Yeah.
Well, how do I know that something is increasing or decreasing? Yeah. The slope is positive. How do we get the slope? We take a derivative, right? Okay, so when we take the derivative, what do we actually get?
Yes.
We get an x value that is when we set it to 0, we get the high or the low, right? Does that make sense what I just said? We actually get the stationary points. So from there, we could figure out, is it going up, 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 then down, or is it going the other way? And the interval of the x's would be the whole grouping that goes increasing or decreasing. We just did one last week about that, or this week even, yes.
So wouldn't that be number 6 is do the second derivative test?
No, the second derivative test is only going to tell you about concavity.
So then,
Well, it's going to tell you whether it is a
Yeah.
max or a min, so you would know to the left of it it's going up. It could work.
but don't you just need to look at the picture and
You
see,
don't necessarily get a picture.
or the chart?
You would make a chart. You could make a chart.
So take the derivative, set it to 0, and then you solve for x, and then you
You
get
look at what's happening to the left and the right of that number.
right, and you usually get 2 numbers, and then you'll say x is less than this, x is
Right.
between, x is greater.
Right.
You plug in a number that falls in that category, and then if it's positive or
Okay, wait, let me
Yeah.
interrupt you. You would plug a number in where?
where you factored it, where it said x minus or x plus a number, and times where you factor that trinomial.
Right, which is the derivative. You would plug it into the derivative.
Yeah.
And when you plug it in the derivative, you would know it's positive is increasing and negative is decreasing. So these are the kind of things that are number 10. Show a triangle is right angled. Okay. What are the what indicates something is right angled? Give me all the descriptions that we know.
Opposite reciprocal slopes.
Okay, beautiful. Opposite reciprocal slopes. So if I have some random triangle drawn, right, and we know the points on the triangle, would you be able to show that it is right angled? Well, sure, you could find the slope of this guy, right, and you could find the slope of this guy, and then tell me that when we have opposite reciprocal slopes, they're perpendicular. So therefore, we have a right angle. Yes?
You could know, well, either if there's more to the picture, you could find that it's 90 degrees by other different angle theorems.
Like sine.
Or if you know the two other angles of the triangle, you know they ought to equal 180 degrees.
Another way to do it. So there's multiple ways, but I've seen it on a test where it says, show that this triangle is right angled. So you have to kind of go back in your tool chest and try to figure out how we're going to do that. Okay, so this particular one, if you really do it with true validity, is probably one of your best review. It's not, here's a problem, do it. Here's a problem, do it. It's like, this is what I'm looking for. How do I approach it? Okay? Does that make sense? All right. So if you notice, and you might remember things, I mean, I've come up with 62 thoughts that go in here, but you might go, oh, this one might be a good one to add. If you think of things, please tell me. Yes?
Question on the interval where it's increasing, decreasing. So you take a derivative, you find the stationary points then, and then you put them into that chart.
You can make a chart. Let's do one. Let's just do an easy one that we know what it looks like. Let's say we're going to do y equals x squared. Okay? Y'all know what it looks like? Okay, it's going to go down to 0 and up, right? We know that the interval that makes it decreasing is going to go from negative infinity, right, to 0.
Yes.
And then it's going to go from 0 to infinity. This is something we absolutely 100% know, but let me show you how you would do it if you didn't. So if it's a function you weren't familiar with. So what you would do is you would take its derivative, right? And then you would take your derivative and you would set it to 0. So what happens when I do that? I get the stationary value. Okay, the stationary value is either
0.
the top or the bottom of that hill.
Right.
At this point, the only thing I know is there's a stationary value. I don't know if it's a max and I don't know if it's a min. Okay, so what I'm going to do is I'm going to take the chart and I'm going to say when x is less than 0 and then when 0 is less than x. Remember, your numbers have to meet up.
Yeah.
Okay, pick a number that falls into each of these categories. So those are the examples, easy ones. Plug them into the first derivative because when the first derivative is bigger than 0, positive, it's increasing. Okay?
Yes.
When the first derivative is less than 0, negative, it's decreasing. Okay? So if I plug this into my first derivative right here, I got 2 times negative 1, which is a negative.
Yes.
That means the first derivative was negative. The first derivative was negative, meaning that it would have decreased, right? So it would have come down, like so.
But so we have to pick in a number that falls in that that satisfies that category. But then, don't we need to have like an inequality there? Like, 'cause how do we know like if it's something, if it's yes or no? Like, don't we have to?
Well, you know that it's decreasing, so you would actually just write the word decreasing.
Because
That's what your question is.
yeah. So the second derivative in this case was.
We're not talking second derivatives at all.
Or I meant first derivative is less than 0 in this case?
Because when I plug it in, I get negative 2, right?
Yeah.
Negative 2 is definitely negative, so it's less than 0.
Yeah.
And then if I do this, 2 times 1 is a positive answer, therefore it would have been greater than 0, so it would have been increasing, which means it goes up like that. Tell me what you know now about the stationary point. It's a minimum.
Yes.
This is what we call sign test. Sign. So one way to do it. Now, could we have done the same kind of thing using the second derivative test?
Yeah.
We could have. Because technically, if you know what the second derivative is, let's go ahead and look at the second derivative, is 2.
Yes.
What do I know about that second derivative?
It's
That means it's,
up like a cup, so a minimum value.
right, it's positive, so it's up like a cup, so it's a minimum value. When I have a minimum value, what happens to the left of it? It's decreasing.
Decreasing.
When I have, and it goes up like that, right?
Yep.
So I would know, this just tells me exactly what that told me.
Hmm.
Same concept. Okay, so question, I had hands up here. Jake?
Oh, is this number 9?
I don't even, I made one up. 6, okay, yeah. Yes.
So in this case, if they asked you that question, you could either do that or the second derivative, or either one will work.
Either one will do it.
Yes.
Whichever one you feel is comfortable
I was
with.
gonna ask about number 11. What do you mean by
11. What the discriminant says, b squared minus 4ac. So tell me everything that you know that you can work with as far as the discriminant is concerned. Yeah, so tell me one. You got it? No?
I was gonna say you can tell if there's 2 roots.
That's exactly what I'm looking for.
Yeah.
If b squared minus 4ac is greater than 0, you got 2
Distinct
roots.
roots.
If b squared minus 4ac is equal to 0,
One double root.
you have one repeated.
Repeated.
What they call it. Mm-hmm.
Isn't that like positive or negative too?
That's
Or-
like this. If it
or no?
looks like
No,
this.
it's like
Oh yeah, like
right?
it hits
That
the.
means this times this. It makes sense that
Yeah.
both the roots are that,
Right.
which is not, they're not distinct. And then the last one is b squared minus 4ac is less than 0. Then we would know that those things would never meet nor touch nor cross.
It's imaginary.
It's imaginary stuff.
Kind of like if you have a parabola where like the vertex is above the x-axis, it's never going to hit the
Never
x-axis.
hits the x-axis, therefore it would be b squared minus 4ac is less than 0.
Yeah.
So that's what I'm looking for. Again, you have to be creative. You have to think, what would the discriminant do for me? When did I use the discriminant, and how would I use it in a test? So you have to kind of go back, and I've asked you all year long, keep your tests, go back and look at how would this subject have affected my tests? You know, because every test you took was 100% from previous tests.
Uh-huh.
Cut and paste, stick it on a page, there's your test. So you would have the idea that it was somehow involved in that learning process.
Yeah.
All right, so now I want to get to statistics, chapter 6.
Okay.
Okay, so you have, although it doesn't look like a lot on the syllabus, you have a lot on the syllabus. And I'm thinking that you guys can, when we're not together, if I'm proctoring and I have a sub or whatever, what I will tell the sub is they have plenty to do, whether it's their test, whether it's their review sheet, whether it's studying for a current test. So I'm never going to give you any more other than what you're learning, but I just want you to be prepared. This is your tool for the rest of the year. Holy cow. It's going to go fast. Okay, so chapter 6 for statistics is going to be talking about probability distribution functions. Probability distribution functions sounds really, really scary. Actually, one of the easier chapters. Because you've learned all the techniques that you have to learn to be able to make them. Now, I say learn with quotes because we've learned them, but how long ago was it? You know, probably before Christmas, right? So we need to review, we need to kind of come back, step back a little bit. And so it takes me a little while to teach this lesson, but once you got the lesson taught, you're like, okay, that's no problem. So, first of all, what's a random variable? Definition. Yes.
Isn't that like where you go out and survey a random group of people?
It could be people.
Mm-hmm.
Number.
No, there's no sync to it. It's just numbers just scattered.
Okay, so the definition that we're going to utilize is the quantity, okay, whose value depends on chance. Oh boy, what does that mean?
Probability.
give me scenarios that numbers depend on chance. Yes.
Rolling a die.
Rolling a die.
Yeah.
I roll a die. What is the chance that I will get a 1?
1 in 6.
Yeah, 1 out of 6. I roll a die. What is the chance I get a 6? 1 out of 6. So what we're talking about now is what we call a random variable.
Uh-huh.
You randomly do a little experiment, right? And the number that you get depends on the chance that you're trying to find. Okay, so they're going to be referencing random variables a lot for this, but you get the topic, I think. Okay. Okay, so let's talk about rolling a die. I'm going to teach you how to make a probability distribution function. Okay, so we're going to roll a die. Things that are important with probability distribution functions, number one, is that you state the experiment that you're trying to test. Okay, so the first one that we're going to do is we're going to let, and it gets a little scary.
The fancy let.
I know, isn't that pretty? We're going to let X, big X, stand for, in quotes, the number, okay, on a die when it is thrown. Okay, so is there any confusion as to what I'm looking for when I'm going to do this experiment? Can everybody envision what the actual experiment looks like? I take a die, I roll it, and I go, oh, there's a 5, right?
Yeah.
So that's what my experiment is. So in this particular case, big X is going to be the actual, what I'm looking for, okay? Then what we do is we have something, we have our next thing is going to be, so the capital X, the large X, stands for the variable itself, okay? Then we're going to have a small x. How in the heck do you indicate between the two? Well, in this case, big X looks like that, and I do like a little curvy curve with the little x. Because sometimes my x's will look the same. So the little x, the small x, is going to stand for the observed values, which the variable takes. Okay. What is my variable in this case? It's rolling a die. What are the possible outcomes? A 1, a 2, a 3, a 4, a 5, a 6. The big X stands for we are rolling a die. The little x stands for the observed values that potentially could happen. Again, they are a 1, a 2, a 3, a 4, a 5, a 6.
Yep.
So my probability distribution function takes the possible observed values. So once again, what are they in this case?
1, 2, 3, 4, 5, 6.
2, 3, 4, 5, and 6. And my bottom part here is the probability that when doing the experiment, what was our experiment? Rolling a die.
Yes.
That we get the little x that we're looking for. Now, can you see how x equals little x is really confusing when you're drawing it quickly? So you make sure that you indicate, like W for big W, I would do like pointed ends for the big W and then little w.
Yeah.
It's hard to decide to distinguish.
It's different.
You have these same letters,
No, I mean like where the capital actually looks different.
like a Q and a Q. I would, yeah, yes.
So it's kind of like when you roll a dice, these are all the possible outcomes you could get, and of that, what is the actual outcome you're going to
What's the
receive?
actual probability that happens?
Yeah.
So, for example, what is the probability when I roll the die, when I produce this experiment, that I get my value of 1?
1/6.
1/6. Perfect.
Yes.
Again, repeat that all the way down. Again, roll the die.
1
6, right?
Yeah.
So I don't think I have to talk about it all the way down, but I think you guys see that each time it is a 1/6 possibility. Yes?
Mm-hmm.
Finally, I always do this little last part. What is the total of the probabilities?
6, 6 all.
6, 6, 1 whole. It had 100%
Yeah.
will always be 1 whole.
Mm-hmm.
Why is that? Because when I talk about every possible outcome, I'm talking about 100% of what happens.
Mm-hmm.
This, my friends, is what we call a probability distribution table.
Yeah.
It's really, really sounds scary. Really, really not bad. Okay? And then we just talk about it and work with it. Now, let's do another one. Let's say that I have 2 red and 3 blue marbles in a bag.
Okay.
And I'm going to take 2 marbles without replacement. Sound familiar? How long has it been that we've done something like that, right? I need to know the probability that I want to know the the number of blue marbles that could potentially be counted. So blue marbles. So what technique would we have done to kind of figure out the experiment?
Tree diagram.
The tree diagram, right? Because
Yes.
this right here, 6 places on a die, you don't need a tree diagram for.
No.
I mean, that's pretty common sense. Tossing a coin, you don't need that. But if it's something that becomes a little bit more extensive, a tree diagram is our best way to go. Multiple trials, right?
Mhm.
So I told you how many? I told you there's two red and 3 blue,
Yeah.
and it's without replacement. So what we're going to do is we're going to start. What's the first scenario that could potentially happen? I could
Red.
pick a red, or I could pick a blue, right?
And it's 2/5 for red.
Well, we'll start with our first. Like I put my hand in the bag, and out comes a whatever color.
Right.
So what is the probability I pick a red?
2/5.
2/5. Does everybody remember how to do that? Remember, this is a good review as well.
The
So
yeah.
2/5 and 3/5.
Yep.
What do I know about those 2 numbers?
They add up to 1
They
whole.
should always add up to 1 whole. Right. Does that make sense? They should always add up to 1 whole. Okay. Now, took red out, put it in my pocket.
Mm-hmm.
Right? I have to go. I'm picking 2. So what's the next scenarios that could happen? I could pick a red again, right? Or I could pick a blue. And the way that this looks, if you were to write it out, is the probability that you pick a red the second time when you had picked a red the first time. That's what that's how we write it. You write however you want to, but that's how. What is the probability that you picked a red again?
1/5 or
Remind me how to do it.
you took 1 away.
Okay, well, no, we're not multiplying yet. We'll get there.
Oh, you can just begin
Right.
to.
So how does that work? Ian? No? I thought you had your hand up. So how does that work? I took one of the reds, right, and stuck it in my pocket. How many reds do I have left?
1.
One.
One.
Once 1 is gone, how many total do I have left?
4.
4. So this is 1/4.
Because once you use it, it's gone. You can't
Gone.
do it.
1/4 is the probability of going a red, given that you already pulled a red.
That's right.
Yes.
So the next one, right? The probability that you picked a blue, given that you pulled a red, right?
Uh-huh.
What is that one?
3/4.
How'd you get it?
Because you already pulled a red, and you have 4 left, and you already have 4 blues.
You have 3 blues still,
Still 3 blues.
but you only have 4 in the bag.
Uh-huh.
Okay, let's do this one down here. Okay. So the next scenario is that I pick a red, given that I picked a blue first, right?
Yeah.
So what happens? Blue's in my pocket. I have how many? I got 2 reds left, but 4 total marbles. And then last but not least, pick blue given blue, right?
2 to 4.
And again, it's 2/4. Everybody cool? Does that ring a bell? Now let's talk multiply. Remember you said that? So how did that work? It was like it's like this. The probability I picked a red and then a red, right? And means to do what?
Okay.
multiply, right? So pick red and red. It would have been 2/5 times 1/4, which is 2/20. You with me? Which is 1/10. What's the next? Yeah,
Didn't you say like and statements are treated as multiply and
Yep.
or means add?
right.
Yeah.
So next scenario is I pick a red and then a blue, right?
Yes.
So red, then blue is 6/20 reduced by 2, 3/10.
How'd you get 2/20?
Okay, so when I multiply 2 times 1 and then 5 times 4.
You don't have to make that 5/20 and then.
Only for
multiply.
addition. When we're multiplying, we go straight across.
Yeah. You don't
Does that
need a
ring a
common
bell?
denominator.
So numerator, numerator, denominator, denominator. Okay? What's the probability I pick a blue than a red? Right?
Yep.
So it's 3/5, 2/4, which is 6/20, which is 3/10.
Mhm.
And then last but not least, blue. What is it? Because it's 3/5 times 2/4, which is 6/20, which is 3/10. Okay.
Add them all up.
And you get 10.
If we add them all up, that's 100% of the possibilities that could have happened, right? Okay, if we add them all up, it should be one whole.
Yep.
Okay? So are we good so far?
Mhm.
Yep. All right. Now, what is... So initially, we did it for everything. We did the whole tree diagram, right?
Yep.
So what is, if I do my little statement here, let's see if I have it written somewhere where you see it better. Okay, so what is the probability that we pick blue marbles? The probability, let X be we pick blue.
Capital X.
Yeah.
Could you do like B and little b? Or do X?
Say it again.
Could you like do the different letter than X and like do B?
You could. Yeah, you could.
It's just you're just doing X.
But you can. It's just X is typically the one you're going to see. So I want you to be able to be familiar with it. It's ugly as sin, but it is what it is. So before we go there, what was the probability that we picked no blue marbles?
1/10.
How'd you get it?
Because that's the only one that doesn't have blue in it.
Right. It's the red, right? So the probability that no blue is 1/10. You with me there? What's the next scenario?
Is that a big X? Or a small?
Little x. This is big.
Okay.
These are scenario. This is story. This is outcome.
So it's AX.
So make it the little pretty. Right.
Yep.
Okay.
What's the next outcome that could have happened? Pick one
The
blue.
order doesn't matter in this case.
Order
right?
doesn't matter in this case, right? So the next scenario that could potentially happen is we picked one blue. The
Uh-huh.
first scenario when we're talking blues is no blue, one blue. This, right?
Or that, so you add.
Right, so you add them, right? It's this and it's this or this. So what was that? 3/10 plus 3/10.
6 times 2 3/6.
Okay. And then what's the last scenario?
Probably that.
Two blues. So what is the scenario that we picked two blues? Well, we kind of had that one all set up for us.
3/10.
Okay. So our probability distribution function will look like this. Scenarios. Probability that x is little x. What were the outcomes that could happen for this story?
0.
We picked none.
0 and 2.
1 or 2.
Yes.
All right. What was 0?
1/10.
1/10. What is 1?
3/5.
3/5. And if you want, you can leave it at 6/10 because what am I putting at the end that they don't?
You add them.
I say total, right? So it's easier to add when they're all common denominators, right?
Oh, yeah.
And then last but not least
3/10.
is 3/10. And we can check to make sure we're good to go. 6 and 3 plus 1 is 10/10. That's what should happen. So total. Yes, go ahead.
But they won't count off if you don't have it reduced right there?
No, not at all.
No.
What do you think so far, probability distribution functions?
It's
really
I like the
No.
diagram, so it's not bad at all.
Would there ever be one at least one blue marble? Will there ever be that?
Yeah, we're gonna talk about that too. Good question.
So that would be, if you add the 1 and 2, it would be 9 tenths.
Right. That's really good. Can you say that again? Ask a question and say it again. So you said, will there ever be
At least one blue.
at least one blue? So what does at least one blue means? It could be 1, right?
Or 2.
2, right?
Or it's just add 6 plus 7.
Right, you add those scenarios. What about at most 1?
Just 1.
Just one.
That would
Or it could be 0.
7 tenths.
0.
Right,
So it
1 or
means
none.
7.
Right. So we'll talk about those scenarios. All right, let me give you another one to try without me. Are you guys feeling good? Okay. We have a spinner.
Uh-huh.
That was a good survey.
So, getting better. Look at that. Okay. Nice. Okay. So, let the story, let big X, right, be the score on the spinner.
Uh-huh.
Okay. I would like you to draw a probability distribution for this. So, you know the story. You spin the wheel and you have a little, you know, and it stops, right? Okay, does that make sense what I'm saying?
Uh-huh.
So the story is you're spinning the wheel and you're going to land on a number.
Mm-hmm.
So create for me a probability distribution function of this story.
Nope. Mm-hmm.
Little x, the probability of big X, including little x and its findings. What are the scenarios that could potentially happen?
1, 2, 3.
1, 2, or 3.
Put them in order, make sure. That's important, I know. Okay, what is the probability that you could spin a 1? 2 out of 8.
Yep.
Also known as 1/4. You leave it whichever way you want. How about number 2?
1/8.
1 out of them.
5/8.
And then last but not least, 5/8, I would say, are the totals where I need them to be? Yes. How was it? It's really not bad,
Do you have to
right?
show the total, or is it just something you want us to do?
I'd like you to make sure you're checking it. Does that make sense?
Yes.
Yeah.
So the next thing I want you to do is this. I'm going to give you a probability distribution function. Let's see what you come up with. I'm not going to give you a title or anything. Let's say it's T. This is a good one. You can decipher between those, right?
Yeah.
All right. Question number 1. Find C.
Oh. See. Oh, yeah. Wouldn't you just add them all up and say that's equal to 1, then solve for C?
That's what I've been telling you. I think it's important to put that little last thing. Total should be 1, right? So to me, it makes sense. Now I know C plus 2C plus 2C plus 2C plus C all should add up to be 1, regardless of what the C is. Does that make sense? So C plus 2C plus 2C plus 2C plus C is 1.
Yes.
So 8C.
So 8C.
C is 1.
Yeah, I went too fast.
Yeah.
C is 1/8.
1/8.
Does that make sense?
Mm-hmm.
Now, could you tell me legitimately what that probability function is, like each
Yeah.
of those things? The distribution table. So what should this be?
1/8.
Oh, 1/8, right? And what's this?
2/8.
2/8. Again, 2/8,
Yep.
2/8, 1/8.
And then all those should be 1.
They should all add up to 1. And we'll finish this. I'll show you, but then we'll finish it. We're going to do something like this.
Okay.
So what would that be?
That's
Less than you.
Least
most
or
3.
Less than or equal to 3. So tell me what numbers fall in that category.
0, 1, 2, 3.
Right, so in this case, what are they?
Or
1, 2, 3.
1, 2, and 3.
1, 2, 3.